Hello, I am Orit, Assistant Professor of Gargi Memorial Institute of Technology. In the today we are study about we are continue the lecture on statistical mechanics. In the last lecture, we are trying to calculate, we are trying to develop the expression for the Fermi energy or Fermi average energy. Okay, in this lecture, first we try to develop the expression for the Fermi velocity of a free electron or a metal Okay, so in the last lecture we have EF is equal to h square by 2m 3 n0 by 8 pi whole to the power 2 by 3. This is the expression of the Fermi energy we have from the last in the last lecture. We already developed this expression for the Fermi energy. Okay, in this lecture, so this is the total energy of the Fermi level for the electron. Okay, so if the total energy is a kinetic energy, because all electrons is now free electrons, that means every electrons have an energy, and that energy is always be a kinetic energy, not be a potential energy. So if the all energy is a kinetic energy, so we can put that half m vf square, vf signify the Fermi velocity, equal to h square by 2m 3 n0 by 8 pi to the power 2 by 3. Okay, where n0 is denoted by n by v, number of particles per unit volume. So from this, if you simplify this expression, vf 2 is cancel out, vf square is equal to become h square by m square 3 n0 by 8 pi whole to the power 2 by 3. If you take a root in the both side, you get vf is equal to h by m 3 n0 by 8 pi 1 by 3. This is the equation 1. This is the Fermi energy. Now if try to calculate the average velocity of electron at T is equal to 0 Kelvin, at absolute temperature, then average V is become 1 by n integration over 0 to Vf V into n function of V dV. It is coming from that side like that, 0 to Vf V n V dV by 0 to Vf n V dV. So in between these velocities, the total number of molecules, just try to divide the total velocity per unit volume is divided by a total number of particles. Okay, so where NV dV is the particles with velocity in range V and V plus dV. Clear? So in between the V and V plus dV velocity range, there is a number of particle on this volume. dV is the smallest volume between the velocity, sorry, not volume, the range actually. In the range between V to V plus dV, the total number of particles is this one, and the expression for the average velocity of electron is coming from this expression. Okay, and we know that we know E is equal to half mv square. So dE is become mv dV if you differentiate this expression. So we know F is a function of energy is always be 1 if energy is less than F. So from this, if the F is become 1, so we can write here that Ne by Ge is equal to Fe. We know that, all know that about this expression. Okay, so it is become Ne dE is equal to Ge dE, because Fe is become 1. Or Ne dE is equal to 8 pi V by H cube for 2m to the power 3 by 2 root E dE. This is the expression for the density of state. So here is a n is a function of energy. If you now consider n is a function of velocity, then 4 pi V, just a minute. So Ne dE 8 pi V by H cube root under 2me m dE. Simplify this expression, just simplify this expression. Now n is a function of V, then if you convert the number of particle is a function of energy to is a function of velocity, so it is become 4 pi V 2m by h square 3 by 2. Put the value of the energy is half mv square to the power half m, and put the value of the dE is mv dV. Clear? Actually we just need this line actually anymore. Just directly distribute this one. Directly distribute the function, because we know the value. Just put the value of E as a half mv square, and the value of the dE is a mv dV. Okay. So if you simplify this one, it is become m8 by V m by h whole to the power 3 V square dV. It is a function of nV dV. Okay, so from equation 2, the average energy is become 1 by n 0 to Vf. V n is a function of V dV. Okay, Actually I am written here as a small one. This is not a small one, it is a capital one. Okay, sorry for the mistake actually. NVDV, so just put the value 1 by n 0 to Vf 8 pi V m by h whole cube V square V cube, it is become V cube actually, because V is multiplied with this V square into dV. 8 pi V by n m by h whole cube Vf to the power 4 by 4. The integral part is become Vf to the 0 to Vf V cube dV. So then after integrate this function, it is become m by h whole cube Vf to the power 4 by 4. Okay, now just simplify this expression. 3 by 4 8 pi by 3n, because V n0 m by h whole cube Vf to the power 4 and n0 is equal to n by V. Okay, and okay, so this is the average energy we have. Okay, we know the value of the Vf cube is h by m whole cube 3n by 8 pi from equation 1. Again we have V bar is equal to 3 by 4 8 pi by 3n m by h whole cube, and just put the value of the Vf, it is become h by m whole cube 3n by 8 pi into Vf. Because we put the value of the V cubes, single Vf is rest in the expression, so this is become 3 by 4 Vf. This is the average velocity of the expression. Okay.